In January 2005, a unique probe was launched into space by NASA. Its mission was to find out where water on Earth came from. This probe was named Deep Impact. It traveled 270 million kilometers through space. After this long journey, it reached close to a comet. Inside this comet were many hidden secrets. These secrets had been searched for centuries. Welcome to Scope History Videos. Viewers, in the entire universe, there is only one place where humans can live. That place is Earth. It feels as if Earth was specially made for humans. Oxygen exists in the atmosphere. In this vast and giant universe, we do not know any other such planet. For now, only Earth supports human life naturally. Humans can live here without any external help. 5 billion years ago, Earth did not exist. The place where Earth is today was empty. This region is located at the edge of the Milky Way galaxy. At that time, instead of planets, there was a huge cloud. This cloud was extremely large. It was made of dust and gases. There was nothing else in it. The question is, what happened in this cloud? How did this cloud transform into a planet? How did it become the Earth we live on today? This cloud is known as a molecular cloud. It contained tiny dust particles. These particles included grains of sand. They also included silicon particles. Various metal particles were present as well. This cloud was formed from dead stars. In the early universe, many stars existed. These stars eventually used up all their fuel. After that, they exploded. These explosions spread particles into space. Over time, these particles formed clouds. This molecular cloud was one of them. It did not look like clouds in the sky. It looked more like images from space telescopes. Similar clouds were captured by the Hubble Space Telescope. The size of this cloud was unimaginable. It was about 100 light years wide. This means light would take 100 years to cross it. That shows how huge it was. In simple terms, it was extremely massive. It was 6 million times larger than the Earth-Sun distance. This cloud is where stars are born. Planets are also formed here. The main force behind this process is gravity. Gravity pulls objects toward each other. Even in space, gravity works. Two objects attract each other due to gravity. The object with more mass has stronger gravity. In the molecular cloud, particles started sticking together. Larger particles attracted smaller ones. These particles collided at high speeds. These collisions produced energy. This energy increased the temperature of the cloud. The core of the cloud became warmer. At the same time, the cloud started spinning. This spinning motion became faster over time. It also kept getting hotter. The speed of rotation increased further. Eventually, the core turned into a massive fireball. This fireball became our sun. The sun formed at the center of the system. The remaining cloud did not disappear. It started orbiting around the sun. This remaining material formed a disk shape. From this disk, planets began to form. But the exact process was still unknown. Scientists did not fully understand it. This remained a mystery for a long time. In the 1700s, a theory was proposed. It was presented by Immanuel Kant. Another scholar, Pierre Simon, supported it. They suggested that stars form from clouds. This idea was called the nebular hypothesis. At that time, it was just a concept. There was no strong evidence. Later, technology improved. Between 1920 and 1950, telescopes advanced. Astronomers observed many such clouds. These clouds were seen in different regions of space. Scientists noticed new stars forming there. However, they could not see inside the clouds. The dense dust blocked the view. This made observation difficult. Later, new types of telescopes were developed. Radio telescopes were invented. Infrared telescopes were also created. These telescopes could see through dust. Now scientists could observe inside the clouds. They discovered young stars forming there. This confirmed earlier theories. It proved that stars are born in such clouds. It also showed how planets form. Planets come from leftover material. But one question still remained. How does this process actually begin? Many ideas were suggested. Scientists tried to explain it, but there was no clear answer. Then in March 2003, an experiment was done. It took place on the International Space Station. Astronaut Don Pettit conducted this experiment. He wanted to study behavior in space. He used simple materials for testing. He created water bubbles. He added dissolving tablets inside them. He also made colored water bubbles. He spun a plastic bag filled with salt. These experiments gave unexpected results. The purpose of these experiments was different, but the final result answered an old question. When the plastic bag was spun, something interesting happened. The salt particles began to stick together. This happened because of attraction in space. Even tiny particles attracted each other. Scientists found this very important. They connected it with space formation. They believed a similar process happened earlier. Inside molecular clouds, particles behaved the same way. Small grains attracted other grains. They slowly started joining together. This marked the beginning of planet formation. About 4.5 billion years ago, this process started. Tiny particles formed small clusters. These clusters kept growing bigger, just like salt grains sticking together. When a cluster reached about 1 kilometer in size, its gravity became strong enough. It started pulling nearby particles toward itself. This process became faster with time. It worked like a vacuum cleaner. It pulled in surrounding dust and gas. This continued for about 3 million years. Eventually, large bodies were formed. Around 20 planets came into existence. These planets started orbiting the Sun. Their paths were around the central star. But this was not the final stage. Another major process was about to begin. These planets were large in size. Each planet had its own gravity. As they moved in their orbits, they came close. Their gravity pulled them toward each other. This led to collisions. Planets crashed into one another. Each collision created a larger planet. 2 planets merged into one. This process repeated many times. Over time, the number of planets decreased. From 20 planets, only a few remained. These included Mercury. Venus was also formed. Mars existed as well. And finally, our Earth remained. But Earth was very different back then. It was not blue or full of life. It was extremely hot. Its surface was like molten lava. It looked like a giant volcano. Scientists believe this stage took 30 million years. At that time, Earth's temperature was about 5,000 degrees Celsius. This temperature was extremely high. No life could survive in such conditions. Any living organism would instantly vaporize. Life could only begin after cooling. But before cooling, another danger existed. This danger came from the sun. These were solar storms. Solar radiation was very powerful. Solar radiation can damage a planet's atmosphere. These solar storms occur on many planets. Because of this, life cannot develop there. Mars is a clear example of this. Mars once had a chance for life, but solar storms destroyed that chance. Its atmosphere was badly affected, but Earth survived this danger. Earth resisted these solar storms. The reason lies inside Earth. The secret is in Earth's core. During formation, Earth became extremely hot. Rocks melted due to high temperature. Inside these rocks were metals. Iron and nickel were present in large amounts. These heavy elements sank toward the center. They formed Earth's core. Scientists studied this deeply. Geophysicists explained an important concept. Molten iron can create a magnetic field. When molten iron spins, it produces energy. This energy creates magnetism. Earth's core contains molten iron. It is constantly moving and spinning. This movement generates a magnetic field. This field surrounds the Earth. It extends far into space. This region is called the magnetosphere. It acts like a protective shield. It protects Earth from solar radiation. On the side facing the sun, this field is strong. It extends up to 370,000 kilometers. This distance is almost equal to the moon's orbit. On the opposite side, it also extends far. It reaches hundreds of thousands of kilometers. This wide field blocks harmful radiation. Solar particles are deflected away. Because of this, Earth's atmosphere is protected. However, at the poles, the field is weaker. Near the north and south poles, radiation can enter. When this radiation enters the atmosphere, it interacts with air particles. This interaction creates beautiful lights. These lights are called auroras. They are also known as northern and southern lights. These lights are harmless to humans. The magnetic field saved Earth from destruction. Earth survived the solar storms, but still, it was not ready for life. Another major event was waiting. This event was a massive collision. To understand this, we go back in time. In the 1960s, humans reached the moon. The Apollo missions were conducted by America. Astronauts collected rock samples from the moon. These samples were brought back to Earth. Scientists carefully studied these rocks. They made surprising discoveries. The moon rocks were very similar to Earth rocks. This raised many questions. These rocks looked almost identical to Earth's rocks. It seemed they had a common origin. Scientists also noticed signs of extreme heat. The rocks appeared to be melted before. This indicated a violent event in the past. Further studies were conducted on these samples. Scientists analyzed oxygen isotopes in the rocks. The isotopes were exactly the same. This proved something important. The moon and Earth were once connected. The moon was once part of Earth. But how did it separate? Scientists searched for an explanation. They concluded a massive collision occurred. Only such a collision could create this effect. A large object must have hit Earth. This object was another planet. It was about the size of Mars. Scientists named this planet Theia. Theia moved toward Earth. Eventually, it collided with Earth. This collision released huge energy. The impact was extremely powerful. It broke parts of Earth apart. Fragments spread into space. Debris from both bodies filled the sky. Over time, these fragments started to gather. They formed a new body in space. This body became the moon. This is how the moon was formed. In the beginning, the moon was very close to Earth. It appeared much larger in the sky. Scientists say it looked 15 times bigger. Over time, the moon moved away. Even today, it is slowly moving away. The distance increases every year. It moves about 1.5 inches per year. This may seem small, but it is constant. This collision changed Earth's future. It made life possible on Earth. The impact caused Earth to tilt. Earth was no longer straight. It tilted at an angle of 23.5 degrees. This tilt had major effects. It created different seasons. Earth rotates on its axis. One rotation equals 1 day. Earth also orbits the sun. One orbit equals 1 year. Because of the tilt, sunlight changes. Some parts receive more sunlight. Others receive less sunlight. This creates summer and winter. Seasons change throughout the year. This is very important for life. It supports plant growth. It helps produce different foods. It controls rainfall cycles. It provides fresh water through rivers. It makes Earth suitable for living beings. The formation of the moon had another benefit. It created tides in the oceans. Ocean tides are very important. They move water across the planet. These tides carry nutrients. Marine life depends on these nutrients. Without tides, nutrients would stay in one place. Life in oceans would struggle to survive, but with tides, nutrients spread everywhere. This supports marine ecosystems. Now a big question arises. Tides need water to exist. But where did Earth's water come from? This was a great mystery. Scientists searched for answers for years. In January 2005, NASA took action. They launched a special probe. This probe was called Deep Impact. Its mission was very important. It was sent far into space. The target was a comet. This comet was named Tempel 1. The distance was 270 million kilometers. The probe carried a special device. This device was a copper impactor. It weighed about 350 kilograms. Its job was to hit the comet. Scientists wanted to study the result. They planned a controlled collision. This would reveal hidden information. On July 4, 2005, the experiment took place. The impactor hit the comet. The speed was 38,000 kilometers per hour. The collision created a huge crater. A large amount of material was released. The probe observed everything carefully. It used special instruments for analysis. Radio telescopes recorded the data. Scientists studied the light from the collision. They used a method called spectroscopy. This method reveals chemical composition. The results were surprising. The comet contained water. This water was in the form of ice. This discovery was very important. It proved that comets carry water. These comets exist far from the sun. Many are found in the asteroid belt. But another question appeared. How did this water reach Earth? Comets are far away from Earth. What brought them closer? Scientists looked for an explanation. They found the answer in a giant planet. This planet is Jupiter. Jupiter is the largest planet. Its gravity is extremely strong. It is much stronger than Earth's gravity. Jupiter is located near the asteroid belt. This position makes it very influential. Scientists believe Jupiter changed comet paths. Normally, comets move in circular orbits, but Jupiter disturbed these paths. Its gravity pulled the comets. Their paths became elliptical. These new paths crossed Earth's orbit. When they came close, Earth pulled them in. Many comets collided with Earth. These impacts brought water. This is how Earth received water. Scientists confirmed this idea. They studied a mineral called zircon. Zircon forms only in the presence of water. It is found in ancient rocks. Zircon contains uranium atoms. Its age can be measured. This is done using radioactive decay. Scientists dated many zircon samples. The results were clear. Zircons are about 4 billion years old. This means water existed at that time. Earth formed 4.5 billion years ago. So water came 500 million years later. By now, Earth had cooled down. Its temperature dropped to about 100 degrees Celsius. Conditions were improving, but one thing was still missing. Oxygen was not present in the atmosphere. Oxygen is essential for life. Without it, life cannot survive. So now a question remains. How did oxygen come to Earth? Tell me your answer in the comments. I hope you liked this Scope History video. Like and share this video. Thank you for your support. See you in the next amazing video.